we're going to find all solutions for z to the power of 4 equals 8 times negative 1 plus square root of 3 times I. In other words, we're getting the fourth roots of 8 times negative 1 plus square root of 3 times I. So let's first let's write this out. We're going to let z equal r times cosine of theta plus I times sine of theta. So if we do to the fourth power, then we have z to the power of 4 equals r to the power of 4. And this is going to be cosine of 4 theta plus I times sine of 4 theta. And again, here our r has to be positive. All right. Now, now that we have this, we're going to be referring to this in a minute. Let's look and see what we have. Our r is going to be the square root, so that's your absolute value of z here, of negative 1 squared plus square root of 3 squared. That's going to be square root of 4. That's going to equal 2. And our angle is going to be equal to where we have tan of, and you take your y divided by x, so square root of 3 divided by negative 1. So that angle is going to be 2 pi divided by 3. So that's what that is. All right. Now that we have that, we need the problem with our thing, we have to find all solutions. So basically, let's look and see what we have. We're going to have 8 times negative 1 plus square root of 3i. This is going to equal 8 times our r. Our r is 2 times cosine. I'm looking at this piece here. Now for all solutions, I'm going to write 2 in pi, because we have to get them all. So this is going to be plus our 2 pi divided by 3. All right, and then you do the same thing with your sine. You want all solutions, so that's going to be 2 in pi plus 2 pi divided by 3. All right, and our n is an integer, so just n is an integer. All right, now that we have that, let's simplify this. You can multiply these two, and you're going to get 16 times cosine of 2 in pi plus 2 pi divided by 3 plus I times sine of 2 in pi plus 2 pi divided by 3. All right, close that up. Now, so therefore, looking at this, our r is going to be, we have r to the power of 4 equals 16. Because this is what we're trying to match up back to this one. So that means my r is 2, which is positive, so that's good. And now we have to match up these. So we're trying to match up this with this. So basically I have 4 theta equals 2 in pi plus 2 pi divided by 3. Therefore, if I divide both sides by 4, I'm going to get theta equals n pi divided by 2 plus pi divided by 6. Now my common denominator is 6. And then if I factor out a pi, I'm going to get this is going to be 3n plus 1 times pi. Now I can rewrite my z to get all my solutions as 2, that's your r, times cosine of 3n plus 1 times pi. I'm going to move this up a little. All divided by 6 plus I times sine, and then we have 3n plus 1 times pi divided by 6, and close that up. Right. So basically, let's put the sign here. All right. So we need another one here. Okay. And this is for our n equals, now since we have this 4 here, we're going to do 0, 1, 2, and 3. And this is the new formula we're going to use for all our solutions. All right, so you might want to write it down, but if we have n equals 0, we're going to get c equals 2 times square root of 3 divided by 2 plus 1/2 times I. Now the 2's will cancel out here, so that's going to give us square root of 3 plus I. All right, for n equals 1, we have c equals 2 times negative 1/2 plus square root of 3 divided by 2 times I. This is going to give me negative 1 plus square root of 3 times I. For n equals 2, we're going to get z equals 2 times negative square root of 3 divided by 2 minus 1/2 times I. This reduces to negative square root of 3 minus I. And then for the last one, we have n equals 3, and that's going to be z equals 2 times 1/2 minus square root of 3 divided by 2i. This is going to give you 1 minus square root of 3 times I. So all your solutions are z equals all of these right here. And that's it. Thank you. Have a nice day. Bye-bye.